Glad to see you here. Today on our agenda, we have a few items. Before we get to today's agenda, though, I would like to just go over a little bit. So I'm trying to get the grade book caught up as much as possible. So I've been grading this morning. I think I've got everything in except 4th hour yet. So that's the 1 hour I just haven't gotten transferred over from Google Classroom over to campus. So we'll be working on that as soon as we're done here. The formative that you took yesterday looked really good. A lot of you did really great stuff on there and gave me some really great examples. Just a reminder, kinetic always means moving. So even if we are in the process of going up a hill, which is a lot of potential, I'm thinking about that bicyclist, that's still kinetic simply because we're still moving, right? To be able to pedal a bicycle, okay? So that's just one that I've seen that is giving some people a little bit of an issue. Each one of those, there were 10 of those at the top. If you haven't done it yet, just know that each one's worth a half a point. I'm still accepting that all through today. So kinetic and potential, again, I'm hoping that this seems redundant and we've gone over it a lot. I hope it looks like for most of you so far, the quiz is going pretty well. Remember, we have to be able to calculate work, but if you haven't looked at the quiz yet, you are given the equation and you're able to use your calculator. So no concerns about that, okay? So make sure you do get out there and get that quiz taken. It's on Socrative, just like we've been doing here in science. What I am going to do, though, is really quickly go through the simple machines assignment that we have for today, just to be able to kind of point out some of the places that I need to make sure that you're putting in information. When I have this up here, a lot of you, I just want to make sure that you see where the parts are that we're looking for information. Now, one thing that I need for you to remember, simple machines are not really what we're studying here, right? Simple machines are something that you were introduced to and learned a lot about and built in 6th grade. So remembering just that concept, however, is that by creating some simple machine, so wheelbarrows, ramps, ladders, pulleys, all of these are different simple machines. If we spread our work out, then we make our work more simple, okay? So that's the big concept really behind a simple machine. However, now what we're doing is we're talking about trying to create, match up the types of energy with each of these places, okay? So this is just a tiny little clip of a Bill Nye. If you haven't gone through this slide presentation yet, this is only about 1.5 minutes, but it kind of just goes through a simple project there that Bill does to show us simple machines at work. I'm not going to play that. We're going to go on to the next one. You guys have the opportunity to go back and look at that. So these are just some examples of some other simple machines that some of these I've already mentioned, right? But a wedge, a screw, thinking about a jar even, or something that we close, being able to use that simple machine, wheels and axles, all of those levers that we have, right? So just thinking about each and every one of those, okay? On here, just this picture, this roller coaster, notice at the very tippy top of that hill, this is where the most potential energy is. And so that has the potential or the ability to create a lot of kinetic energy, right? So just that review of that again, okay? So here, this space right here. So after you watch this little what is an inclined plane, then it's just as I was asking you to put down some information here, just some things that you noticed while you were going through the slide presentation. Right here, just again, jot down your thoughts below. It says, where do you find some examples of inclined planes? So you can probably come up with quite a few, just thinking about that. And then this one, how does an inclined plane help us to now create potential energy? So this is kind of the basis of where we're really trying to get to. By utilizing these simple machines, how can we now label where is the potential energy, what is the energy that's created after that potential energy is changed into something else, okay? Then this is the last piece of it, and that I said in here to go ahead and use your science book to create an inclined plane, but you can use anything. If you've got another book next to you or some other way that you would like to create an inclined plane, go right ahead and do that. But I need you to put your pencil or your pen at the top of the plane that you've created and then allow it to roll down. So then you're going to think about, where does the pencil have the most potential energy? Where does the pencil have the most kinetic energy? Okay, so those differences. So once you have created your simple machine of an inclined plane, then I want you to take a picture of it. So you can just have the picture of the inclined plane. If you have the pencil sitting at the top and you're able to get the picture of it before it rolls down, that's great. If not, no big deal, but just inserting that image on this very last slide, okay? So some of you have already gone through this. That's great. I just wanted to make sure that I went through. If you have any questions about that slide presentation, don't hesitate to ask, or just check in with me later about that. But I think it shouldn't really take that long. It's pretty straightforward, okay? Then the other thing that I'm asking you to do today is to take that quiz. And I've already talked a little bit about it, but out there on Socrative.com, and the link is right there on today's daily agenda. If you click on that, then it asks you to put in the room name, like we've done so many times already, which is my last name. And then you're putting in your name. And you can put last first or first last. I'll still figure out who it is, right? And then that score out of 10 is going to go in the grade book. So just make sure that you take your time. So one thing that I've seen is we get going on these quizzes, and even though I say it over and over, be sure to take your time, go back and double check your answers before you click end or submit, okay? I just want to make sure that you have that opportunity to look at and think about your answers before you submit them. Yes, and another reminder again, you can use your calculator. I'm not looking for your math skills right here. I'm looking for you to be able to plug in the numbers into the equation that we do know and be able to solve once we have those plugged into that correct space, okay? So again, you're given that equation. If you haven't taken that quiz, no worries about memorizing anything as far as the equation. However, we're needing to understand work is measured in joules, force is measured in newtons, and the distance that we're working with is meters, okay? So pretty straightforward today. If you have any questions, please stay on. If you have any issues with your Chromebook camera or getting that picture inserted, email me, let me know what's going on there. But again, pretty straightforward. If we go up to insert and then go down to image, use your camera, it'll just put it right into that exact spot where you need it to happen, okay? All right, that's all I have for you today. Pretty short and sweet, but make sure you get that quiz taken and you get your slide presentation turned in. Have a great day, everybody.